The end of the Clone Wars marked the start of a new era. The Republic had transformed into the Empire, a totalitarian regime that sought to impose order on a galaxy scarred by conflict. While the Republic had fought to maintain peace and stability, the Empire's strategy was built on intimidation, control, and overwhelming force. As a result, its military doctrine had to change. Under the Republic, starfighters like the ARC-170 and the V-Wing were designed for multi-role capabilities, long-range missions, durability, and advanced systems like hyperdrives and shields. These fighters reflected the Republic's need for versatile ships in a galaxy-wide conflict against a technologically advanced enemy, the Separatists. However, once Emperor Palpatine established his grip on power, his vision for the military shifted. Instead of focusing on costly, versatile starfighters, the Empire required a new doctrine, one that prioritized the rapid production of massive fleets to maintain control over the galaxy and enforce its will on countless star systems. Centralized control, fear, and mass deployment became key pillars of this doctrine, and Palpatine's vision demanded that starfighters reflect these principles. The Empire's primary enemies at this point were no longer droid armies or organized fleets, but rather dissidents, small rebel cells, and insurgents who would try to rise against Imperial rule. The Empire's military needed to suppress these threats by overwhelming them with sheer force, and a new starfighter would be central to this strategy. To equip this new military, Palpatine and his advisors initiated a rearmament program designed to build a massive fleet that could patrol and subdue the galaxy. They announced a competition for corporations to submit proposals for a new starfighter that would embody the Empire's doctrine. It had to be fast, maneuverable, cheap, and easily mass-produced. Cost-effectiveness and mass production were key, because the Empire envisioned overwhelming its enemies with sheer numbers. Several prominent starship manufacturers vied for the contract, seeing the opportunity as a gateway to untold profits and influence within the Empire. Among these companies were Rendalee Stardrive, Kuat Systems Engineering, and CNR Fleet Systems. Each had a long history of producing starships, from capital ships to starfighters, and each had established itself as a key player during the Clone Wars. CNR Fleet Systems, led by Wraith CNR, had made its mark during the Clone Wars by developing advanced technology for both the Republic and the Separatists, including the predecessor to the TIE Fighter, the V-Wing. Wraith CNR had a reputation for bold, innovative designs, and his company understood how to capitalize on changing political and military needs. Unlike its competitors, who pitched designs based on sturdier, more versatile ships, CNR Fleet Systems realized the new Empire needed something radically different. A starfighter that could be deployed in massive numbers at minimal cost, embodying the Empire's strategy of swarming tactics. The competition to secure the Empire's starfighter contract was fierce, with rival corporations engaging in underhanded tactics and political maneuvering to secure their designs as the Empire's top choice. Rendalee Stardrive and Kuat Systems Engineering, both famous for their capital ships, entered the competition with designs based on their established philosophies: durable, heavily armed starfighters with shields, hyperdrives, and a focus on pilot safety. These companies had strong political connections and had been major suppliers to the Republic during the Clone Wars, giving them a perceived advantage in the bidding process. However, CNR Fleet Systems, which had already started developing its twin-ion engine TIE technology, recognized that the Empire's priorities were changing. They emphasized their design's cost efficiency, its ability to be produced at scale, and the fact that it perfectly aligned with the Empire's need for mass deployment rather than individual pilot survivability. The TIE design was revolutionary in its minimalism. It lacked the hyperdrives, shields, and life support systems found in other starfighters. These features were unnecessary for the TIE's role as a short-range, fleet-based fighter, designed to be deployed in waves from massive star destroyers. CNR also used its political savvy to secure the contract. While Kuat and Rendalee focused on the Senate and military officials who still held some sway from the Republic era, CNR directly courted the new power structure of the Empire, focusing on figures like Wilhuff Tarkin and other key military leaders who were aligned with Palpatine's vision. These leaders recognized that the TIE Fighter represented the future of the Imperial Navy, a future built on efficiency, mass production, and dominance through numbers. Wraith CNR's personal influence and foresight also played a key role. He positioned his company not just as a Starfighter manufacturer, but as a symbol of the Empire's new order. CNR Fleet Systems presented its TIE fighter not merely as a product, but as an embodiment of the Empire's military doctrine: fast, intimidating, and utterly disposable, reflecting the Empire's disregard for individual lives in favor of collective power. The iconic screech of the TIE fighter as it streaks through space is perhaps one of the most recognizable sounds in the galaxy. This signature sound is produced by the revolutionary propulsion system that powers the TIE series, the Twin Ion Engine, TIE. Developed years before the Clone Wars, the Twin Ion Engine would go on to become the backbone of the Empire's Starfighter fleet. Its design was born out of scientific experimentation, bold innovation, and the vision of one man, Wraith CNR. The journey of how the TIE system was conceived, tested, and implemented offers a glimpse into the technological and strategic shifts that occurred in the galaxy in the lead-up to the rise of the Empire. Wraith CNR, the brilliant engineer and founder of CNR Fleet Systems, was a pioneer in starship design. His genius lay in his ability to not only create advanced technologies, but to foresee the direction of galactic warfare and the role these technologies would play. Long before the rise of the Empire, even before the Clone Wars began, CNR was already making significant contributions to the field of spacecraft propulsion. He was fascinated by speed, maneuverability, and efficiency in starship design, qualities he believed would define future space combat. In the waning years of the Galactic Republic, CNR sought to develop a starfighter propulsion system that was lightweight, highly efficient, and capable of providing unparalleled agility. His work led him to experiment with ion engines, a type of propulsion system that used ionized particles to generate thrust. Ion engines, though already in use in the galaxy, were mostly relegated to low-power applications, as they were generally seen as inferior to other forms of propulsion in terms of raw speed and output. However, CNR saw potential in ion engines if they could be refined and developed further. He envisioned a new class of ion engine that would be capable of powering small, agile spacecraft. The result of his research would be the creation of the Twin Ion Engine, TI system, an innovative propulsion method that would become the cornerstone of one of the most infamous Starfighter series in galactic history. The Twin Ion Engine was a leap forward in starship propulsion. Traditional ion engines worked by accelerating ionized particles through an electric field, which would generate a small but consistent amount of thrust. These engines were efficient for long-term, sustained travel in space, but were generally not powerful enough for quick maneuvers or high-speed combat situations. CNR's breakthrough was in the creation of a dual-engine system that doubled the ion output, allowing for greater thrust and speed, while still maintaining the energy efficiency for which ion engines were known. By focusing on ionized gas acceleration, CNR designed the TI to produce high velocities without consuming excessive amounts of fuel. The simplicity of the design also meant that TI engines could be built cheaply and quickly, a key advantage for mass production. The TI system was configured so that ionized gas was accelerated through two parallel accelerators, which created an immense amount of thrust relative to the small size of the craft. CNR's engines were also notable for their ability to operate without traditional fuel-based combustion. Instead of using hypermatter or other volatile substances, TIE engines relied on solar collectors mounted on the wings of the fighter, which absorbed energy directly from nearby stars or from artificial power sources aboard capital ships. This solar energy was then converted into ionized particles that would be ejected through the twin engines, propelling the craft forward. This not only reduced the fighter's reliance on external fuel sources, but also made the engines extremely lightweight, freeing up more room for maneuverability and speed. Designing the Twin Ion Engine was not without its challenges. Wraith CNR and his team of engineers had to balance power output with energy efficiency, while ensuring that the engines could withstand the rigors of combat. One of the primary concerns was heat dissipation. Ion engines generated a significant amount of heat, especially when configured in a twin setup. CNR's team experimented with various cooling systems, eventually settling on a design that used the craft's hull as a heatsink. allowing excess heat to dissipate into space. The first tests of the twin-ion engine took place in secret at one of CNR Fleet Systems' private research stations. Early prototypes of the TIE engines were fitted to small test ships, which were launched in controlled environments to measure their performance. These tests revealed the engine's exceptional maneuverability and speed in space, although some adjustments had to be made to improve stability during sharp turns and acceleration. Over time, the engines were refined and subjected to increasingly rigorous tests, including simulated combat scenarios. The results were promising. The TIE engines provided a level of maneuverability that was unmatched by any other propulsion system at the time. Fighters equipped with these engines could perform tight turns, rapid acceleration, and quick stops, making them ideal for close-quarters dogfighting. One of the first experimental ships to use an early version of the twin-ion engine was the Sith Infiltrator, a sleek, advanced starship used by Darth Maul during the final days of the Republic. Officially known as the Scimitar, this vessel was a prototype that incorporated CNR's cutting-edge technologies. While the Scimitar wasn't powered by the fully realized twin-ion engine system, it did feature a similar ion-based propulsion system that allowed it to achieve remarkable speed and stealth capabilities. The Scimitar's propulsion system also included solar collectors similar to those that would be found in later TIE fighters. Darth Maul's Scimitar was equipped with cloaking technology, a hyperdrive, and an advanced weapons suite, but it was its propulsion system that made it truly remarkable. The ion engines provided the ship with a near-silent running capability, which, combined with its cloaking device, made it virtually invisible to enemy sensors. While the Scimitar was a one-of-a-kind vessel designed for covert operations, its use of ion engines demonstrated the potential of CNR's technology for future starfighters. Following the success of the Scimitar's propulsion system, CNR Fleet Systems began to experiment with other prototype ships using variations of the twin-ion engine. These experimental vessels were designed primarily for speed and agility, and they served as testbeds for the technology that would later be fully realized in the TIE Fighter series. Many of these early prototypes were used in clandestine missions or as escort craft for high-ranking officials, but they were never mass-produced due to the high cost of their advanced systems. The final iteration of the twin-ion engine, as seen in the TIE Fighter, provided the Empire with a starfighter that was perfectly suited for the kind of combat the Imperial Navy envisioned. The TIE engine allowed the fighter to reach high speeds, outpacing many of its contemporaries in a straight line. Its maneuverability was unparalleled, enabling TIE pilots to execute sharp turns, sudden stops, and rapid accelerations that could disorient and outflank opponents in dogfights. Unlike other starfighter propulsion systems, which relied on heavy fuel loads or complex power generators, the TIE's solar-based ion engines made the ship incredibly lightweight. This, combined with the fighter's lack of shields and armor, made it one of the most agile craft in the galaxy. However, this speed and maneuverability came at a cost. TIE fighters were vulnerable to even the smallest damage, as they lacked shields, heavy armor, and hyperdrives. The disposable nature of the TIE fighter was by design. The Empire envisioned massive waves of TIEs overwhelming enemy forces through sheer numbers and relentless attacks. The engines, therefore, were designed for short-range engagements, making them perfect for deployment from star destroyers and other capital ships. With their low operational cost and high agility, TIE fighters became the perfect tool for the Empire's strategy of intimidation and dominance. The twin-ion engine would go on to power not only the standard TIE fighter, but also a wide variety of other Imperial starfighters, including the TIE Bomber, TIE Interceptor, and TIE Defender. Each of these variants used the same basic propulsion system, albeit with modifications to suit their specific roles. The TIE series as a whole became synonymous with the Empire's military might, and the distinctive screech of their engines became a symbol of Imperial oppression across the galaxy. Wraith CNR's vision for a simple, efficient, and powerful propulsion system had been fully realized in the twin-ion engine. By developing a system that could be mass-produced at minimal cost while offering high performance in combat, CNR Fleet Systems had secured its place as one of the most important corporations in the galaxy. The TIE Fighter and its variants would go on to play a central role in the Empire's efforts to maintain control over the galaxy, and the legacy of the twin-ion engine would continue to shape space combat for years to come. The The TIE Fighter's hull was made primarily from quadanium steel plating, a tough but lightweight alloy commonly used in Imperial starfighters. Quadanium steel was chosen for its ability to resist damage from small arms and handheld blasters, providing a certain degree of protection for the cockpit. However, the starfighter's armor was kept deliberately light, as the Empire prioritized speed and maneuverability over durability. The plating was effective against light impacts and environmental hazards, but vulnerable to direct hits from military-grade laser cannons and heavy blaster weapons, as well as micrometeor strikes in space. The cockpit sphere was carefully engineered to maximize structural integrity while minimizing mass. Its spherical design was not only aesthetically iconic, but also functional, as it allowed glancing blows from weapons fire to be deflected. However, the cockpit and the attached wing pylons had weak points at the joints, where damage could cause catastrophic failures in flight, especially if one of the wings was hit. The lack of deflector shields was a deliberate design choice aimed at reducing the fighter's mass, cost, and energy consumption. The philosophy behind this was simple. Rather than provide each ship with individual protection, the Empire would overwhelm the enemy with large numbers of TIE Fighters, making individual survivability less of a priority. The TIE Fighter's iconic wings were actually large solar arrays designed to absorb energy from nearby stars or artificial light sources. These solar collectors, 12 in total, were integrated into the fighter's broad, flat wings, which were framed by rigid quadanium steel foil braces. The microcrenulated solar absorption surface on the panels allowed the TIE Fighter to absorb vast amounts of solar energy and direct it to the ship's power systems. Early designs had the solar panels powering both the engines and the ship's weapons, but this dual usage proved problematic, as it drained energy too quickly and hampered the TIE's performance. Later models, including the TIE line, were outfitted with dedicated power generators for the laser cannons, resolving the issue and enhancing the fighter's combat effectiveness. In addition to being energy sources, the wings also functioned as stabilizers, helping maintain the fighter's balance and agility during sharp maneuvers. This was especially important in the vacuum of space, where even slight imbalances could result in uncontrolled spins. The wings were strong enough to serve as landing gear for vertical takeoff and landing, VTOL, when combined with the TIE Fighter's repulsor lift cyclers, which reduced the overall mass of the craft by counteracting the gravitational pull on planetary surfaces. However, the wings presented a drawback in atmospheric combat. Their broad, flat surface created resistance, making it more difficult to maneuver at high speeds in atmospheres with significant crosswinds. The wings also obstructed the pilot's peripheral vision, forcing them to rely on targeting systems and sensor arrays to compensate for the blind spots. The TIE Fighter's primary armament consisted of two LS-1 low-temperature laser cannons mounted beneath the cockpit. These laser cannons were effective against lightly armored starfighters and unshielded targets, providing the TIE Fighter with the ability to engage enemy craft like Rebel X-Wings and A-Wings in rapid dogfights. By the time of the Battle of Endor, the TIE line models had upgraded their weapon systems to the LS-7.2 laser cannons, which provided enhanced firepower and efficiency. The Empire made use of a green blaster bolt from these weapons, a result of using more expensive blaster gas in the Empire's munitions. The choice of green bolts was practical. It made it easier for pilots to see their shots in the chaos of battle and adjust their aim accordingly. The laser cannons were tied to an advanced TS-8 targeting computer, later upgraded to the TS-9A model, which allowed for rapid target acquisition. These computers were superior to the models used in Rebel Alliance fighters and allowed for quicker target locks, giving Imperial pilots a significant advantage in dogfights. Despite its effective weaponry, the TIE Fighter had no secondary weapons like proton torpedoes or missiles as standard. However, some TIE Fighters were later retrofitted with additional armaments, including ion cannons or missile launchers, depending on the mission profile. These retrofit options increased the fighter's versatility, allowing it to engage larger ships or more heavily armored targets when necessary. The cockpit of the TIE Fighter was an exercise in Imperial pragmatism. It was small, cramped, and minimalist in design, providing just enough space for a single pilot. The interior was dominated by the flight controls, targeting systems, and sensor equipment, all of which were designed to prioritize combat efficiency over comfort. The forward-facing transparasteel viewport was the pilot's primary visual interface with the outside environment, though it offered limited visibility due to the obstructive wings on either side of the cockpit. For survival in space, the cockpit featured a pressurized seal and minimal life support systems, including oxygen scrubbers that allowed the pilot to breathe for the duration of a short mission. However, the lack of extensive life support meant that pilots were required to wear specialized flight suits and vacuum-sealed helmets. These suits provided the pilot with additional oxygen, temperature regulation, and protection against the vacuum of space in the event of a hull breach. The TIE Fighter's flight controls were noted for their ease of use, and even Rebel pilots who had stolen the craft found them to be highly intuitive. The controls allowed for precision flying, and the ship's natural agility and responsiveness made it an ideal dogfighting craft. In case of emergencies, the TIE Fighter was also equipped with an ejector seat with built-in anti-grav units and parachutes, allowing the pilot to escape a doomed craft safely. The sensor suite within the TIE Fighter included tracking equipment and targeting systems that helped pilots lock onto enemy targets despite the limited visual field. Additionally, a homing beacon was installed as a security feature in case the fighter was stolen or lost, enabling the Empire to track and recover the craft. The TIE Fighter's greatest asset in battle was its maneuverability. Its twin-ion engines provided incredible thrust and allowed the fighter to make sharp turns and evasive maneuvers at high speed. The addition of W-401 maneuvering jets and repulsor lift cyclers further enhanced the fighter's ability to quickly adjust direction and speed in space or planetary atmospheres. In atmospheric conditions, however, the TIE Fighter faced significant challenges. The broad wings created drag, making it more difficult to steer, especially in high wind or crosswind conditions. At low altitudes, particularly in urban environments, the TIE Fighter could hold its own against Rebel starfighters, but at higher altitudes, it struggled to maintain stability in fast, high-altitude dogfights. Despite its agility, the TIE Fighter was designed for space combat and short-range engagements, where its lack of durability and shields mattered less than its ability to outmaneuver and outgun enemy fighters in large numbers. TIE pilots were trained to rely on Imperial tactics that emphasized squadron coordination and overwhelming force, as the TIE Fighter's weaknesses were most apparent when facing enemies alone. The TIE Fighter was a masterclass in Imperial efficiency and cold pragmatism. Its design was built around the idea of rapid mass production, speed, and maneuverability at the expense of durability and protection. With its lightweight quadanium steel frame, solar-collecting wings, and powerful laser cannons, the TIE Fighter could dominate the skies when deployed in the vast numbers characteristic of the Galactic Empire. Though its lack of shields, minimal life support systems, and vulnerability in atmospheric conditions were often seen as drawbacks, the TIE Fighter's impressive agility and the Empire's doctrine of overwhelming force made it a critical tool in Imperial space superiority. The fighter's ability to strike fear into enemies with its iconic engine howl and deadly laser cannons, combined with its ease of maintenance and mass production, made the TIE Fighter an enduring symbol of the Empire's military might. The earliest generation of TIE Fighter pilots came from the remnants of the Clone Wars. These first pilots were clones of Jango Fett, veterans who had once served in the Republic Starfighter Corps. As the Galactic Empire rose from the ashes of the Republic, these clone troopers, engineered for obedience and combat prowess, were repurposed for the Empire's new starfighters, the TIE Fighters. The transition from the Republic's heavily shielded starfighters, like the ARC-170, to the Empire's minimalistic shieldless TIE models was swift and brutal. These early clone pilots were primarily Jango Fett clones, selected for their physical and mental capabilities. However, over time, the most skilled of these clones were elevated to the status of prime clones, whose genetic material was used to create new generations of pilots. These prime clones, distinguished by their black dress uniforms, symbolized the Empire's reliance on genetic engineering for its war machine. Despite their skills and the prestige of their origins, clone pilots were treated as expendable, a fact that would shape the culture of TIE pilots for generations to come. The Empire's early decision to use clones contributed to a deep-seated belief that TIE pilots were disposable, and this belief extended even to the design of their starfighters. The TIE fighters themselves were stripped down, lacking deflector shields, hyperdrives, or life support systems. This lack of protection underscored the Empire's brutal efficiency, where survival was secondary to the mission. Clones, conditioned for obedience, accepted their expendability, but the arrival of human pilots from the Imperial academies would soon complicate this dynamic. As the Empire solidified its hold over the galaxy, the reliance on clone soldiers waned, and human recruits began to fill the ranks of the Imperial Navy. The transition from clone pilots to human graduates of the Imperial Academy marked a significant cultural shift within the Starfighter Corps. Unlike clones, these human pilots were not bred for war. They had to undergo grueling training to earn their place in the cockpit of a TIE fighter. Yet, despite the human pilots' increasing numbers, they inherited the same expendable role as their clone predecessors. The Imperial Academy was notorious for its harsh, uncompromising training programs. Cadets were subjected to both physical and psychological conditioning that molded them into fanatically loyal soldiers. Out of every 100 recruits, only about 10 would survive the rigorous testing to become TIE pilots. The rest were reassigned to less glamorous roles: combat gunners, crewmen, or other naval personnel. The TIE Pilot Corps represented the elite of the Imperial Navy, not just for their skills, but for their resilience in surviving one of the most brutal selection processes in the galaxy. One of the most significant aspects of TIE pilot culture was the idea of expendability. From the moment they began their training, pilots were conditioned to view themselves as tools of the Empire, with the mission always taking precedence over personal safety. This mindset was further reinforced by the Empire's insistence on using disposable, low-cost starfighters. The TIE fighter, a symbol of Imperial might, also symbolized the Empire's willingness to sacrifice its pilots in battle. This culture of expendability was so deeply ingrained that many pilots took pride in their lack of protection, viewing it as a testament to their skill and dedication. However, there were exceptions to this attitude. Certain Imperial officers, like the legendary TIE ace Shea Hublin, argued for better protection for the pilots. Hublin's campaigns to redesign TIE fighters with shields and life support systems were met with resistance from the Imperial hierarchy. The Imperial Navy's leadership, fixated on cost efficiency and mass production, dismissed these proposals. Ironically, the pilots themselves often rejected the idea of additional protection, seeing it as unnecessary or even cowardly. Becoming a TIE pilot was no small feat. Prospective pilots had to pass through one of the Empire's highly competitive flight schools, which were located across the galaxy, from asteroid bases to capital ships. Those who survived the selection process spent the next year undergoing rigorous training. Each cadet was assigned a partner, and together they were drilled in hundreds of hours of flight training, learning how to operate as a team in combat scenarios. However, training was as dangerous as real combat. Many cadets perished during live combat missions, which were used as part of their training regimen. The constant threat of death weeded out the weak, leaving only the most capable to advance into the Starfighter Corps. Once accepted as TIE pilots, their identities were stripped away. Personal names were replaced with identification numbers like DS-612. This was not merely a symbolic gesture. By erasing personal identity, the Empire reinforced the idea that pilots were tools of the Imperial war machine, rather than individuals. This dehumanization was further compounded by their flight training. Pilots were continually reminded of their starfighters' lack of integrated life support and combat deflector shields, with the use of such systems being seen as a sign of cowardice. Psychological conditioning was an integral part of their training. TIE pilots were taught to view themselves as expendable, and this mentality was ingrained through constant indoctrination. Loyalty to the Emperor and the mission was absolute. Failure to complete a mission, or worse, retreating from combat, was seen as a betrayal of the Empire. The conditioning was so extreme that pilots were often willing to sacrifice their lives and those of their wingmen to achieve victory. Life within the TIE Pilot Corps was a blend of camaraderie and isolation. Pilots were known for their close-knit bonds, forged through the shared hardship of training and combat. However, this camaraderie was largely restricted to their own kind. TIE pilots often avoided social interaction with other Imperial personnel, preferring to keep to themselves. This was partly due to their shared experiences, but also because of the psychological conditioning that kept them emotionally unstable. The Empire believed that keeping pilots in a constant state of insecurity would make them more effective in combat, though this often led to trouble in their personal relationships. A deep rivalry existed between TIE pilots stationed in the Imperial Navy and those assigned to the Imperial Army's ground support wings. The Navy pilots, who often viewed themselves as superior, referred to their Army counterparts as groundhogs, while the Army pilots derisively called their Navy peers vac-heads. This rivalry was so intense that it frequently led to violent clashes in cantinas and other social spaces, prompting many cantina owners to separate the two groups to avoid brawls. Despite their close bonds, TIE pilots were conditioned to prioritize the mission above all else, even at the expense of their comrades. During combat, if a wingman was in danger, pilots were expected to stay focused on their objectives rather than risk their own lives to assist. This brutal prioritization of the mission over personal relationships reinforced the idea that individual pilots were dispensable. Combat for a TIE pilot was unforgiving. Strapped into the cockpit of a shieldless starfighter with minimal life support, TIE pilots relied solely on their skills and quick reflexes to survive. The control system of a TIE fighter was notoriously claustrophobic. Pilots used their feet to operate the control yokes and their hands to grip control rods. With their bodies strapped into shock couches, they were constantly aware of the fragility of their situation. One wrong move could mean instant death. Despite these harsh conditions, many TIE pilots took pride in their craft. The best of them considered the TIE fighter to be the finest starfighter in the galaxy, relishing the challenge of flying without the protections that other starfighters afforded. In battle, TIE pilots often flew in formations of up to 5 ships, with strict adherence to military discipline. However, if their leader was shot down, the remaining pilots were prone to scattering, a consequence of the Empire's strategy of using inexperienced pilots in large numbers. The mortality rate among TIE pilots was astonishingly high, earning them the grim nickname "coffin jockeys" among Imperial personnel. This high turnover meant that most pilots never flew the same ship more than once. However, as the Empire's resources dwindled, especially during the reign of Grand Admiral Thrawn and the reborn Emperor Palpatine, pilots and ships became more valuable. TIE interceptors were eventually equipped with deflector shields, and unmanned TIE-D automated starfighters were used to support living pilots. Despite their early expendability, the legacy of the TIE pilots evolved over time. As the Empire began to falter, Imperial commanders like Grand Admiral Thrawn recognized the value of their skilled pilots. Under his leadership, the once disposable TIE pilots became more of an elite force, and greater care was taken to protect them in combat. TIE interceptors were fitted with deflector shields, and the Empire began to develop more advanced starfighters, such as the TIE Defender, to match the growing threat of the Rebel Alliance. However, the culture of sacrifice and loyalty remained. Even as the Empire's resources dwindled, TIE pilots were still expected to place the mission and the Emperor above their own lives. Their training, conditioning, and indoctrination had shaped them into instruments of the Empire's will, and their legacy would endure long after the fall of the Galactic Empire. The TIE Fighter, as the backbone of the Galactic Empire's starfighter fleet, required constant and rigorous maintenance to ensure peak performance and combat readiness. Given the mass-produced, expendable nature of the TIE series, the Empire placed heavy emphasis on efficient maintenance processes that could support large-scale operations with minimal downtime. Unlike Rebel starfighters, which were often equipped with shields, hyperdrives, and more advanced onboard systems, TIE fighters were designed with simplicity and mass deployment in mind. This approach influenced the way these ships were maintained and repaired throughout their service life. Imperial doctrine viewed TIE fighters as disposable assets, which influenced their design and maintenance routines. The lack of deflector shields, life support systems, and hyperdrives meant fewer components that required upkeep, but it also necessitated more frequent checks on the fighter's core systems, especially the twin-ion engines and laser cannons, which were critical to their functionality. The maintenance strategy was designed to be efficient and fast, allowing TIE fighters to return to combat as quickly as possible. With the Empire's vast resources, TIEs were often repaired with minimal effort, or even scrapped if they were too damaged to be restored quickly. This philosophy contrasted with the Rebel Alliance's approach, where starfighters were often maintained with care and repaired multiple times due to resource constraints. The Imperial Navy operated under strict maintenance protocols to manage the thousands of TI fighters aboard its fleet of star destroyers, battle stations, and planetary garrisons. These protocols ensured that each TIE received regular attention despite the high volume of fighters. The procedures were broken down into several key phases. Before every mission, each TIE fighter underwent a basic pre-flight check. Technicians ensured that the engines, weapons, and control systems were operational. Fuel levels, for short-range operations, and oxygen supplies, for pilots' survival suits, were verified, though the absence of onboard life support systems reduced the overall complexity of these checks. Any immediate concerns were addressed quickly to get the fighter into combat as fast as possible. After every sortie or battle, TIE fighters were subject to detailed evaluations. This involved scanning for damage, engine wear, and weapon system depletion. Any minor damage was repaired on site, while more significant issues required the fighter to be taken out of rotation for more extensive work. Pilots would often report any abnormalities they encountered during flight, which helped maintenance crews prioritize repairs. While TIE fighters were typically treated as expendable, the Empire still conducted periodic overhauls of its fleet. These overhauls occurred every few months and involved deeper diagnostics and component replacements. TIEs that survived multiple battles were often stripped down to their base frame, with critical systems like engines, weapons, and avionics being either replaced or refurbished. Overhauls were particularly important for older TIE models, which were more prone to malfunctions due to prolonged exposure to combat. The Empire maintained vast fleets, which required dedicated maintenance facilities for their TIE squadrons. On large vessels like star destroyers, entire hangar bays were dedicated to the servicing of TIE fighters, equipped with specialized tools and equipment. Each Imperial Star Destroyer carried dozens of TIE fighters, with maintenance crews working around the clock in the massive hangar bays to keep the fighters in combat-ready condition. These hangars were equipped with ion drive diagnostic stations, laser cannon calibration tools, and repair stations for the solar panels. Refueling stations allowed technicians to replenish the ship's fuel cells after each mission. Key space stations, such as Death Stars or orbital battle stations, housed significant TIE maintenance facilities, where entire wings of TIE fighters could be overhauled simultaneously. Ground-based garrisons, particularly those on crucial Imperial worlds, also featured TIE maintenance bays, though these were smaller in scale and focused on supporting local defense squadrons. Although TIE fighters did not carry astromech droids, like many Rebel ships did, maintenance bays often employed droids to assist with diagnostics and repairs. These droids ran system scans, reported issues, and helped manage the massive flow of TIs through the maintenance process. MSE-6, mouse droids, were often used to transport parts and deliver tools across the large hangar bays of Imperial vessels. The scale of TIE fighter operations required a massive logistics network to supply parts, tools, and fuel to Imperial fleets. CNR Fleet Systems, the primary manufacturer of TIE fighters, was responsible for producing millions of spare parts, from ion engine components to solar panel assemblies. These parts were distributed across the galaxy to key Imperial installations and warships. The Empire maintained an extensive supply chain that ensured TIE parts were available at every major Imperial outpost. Star Destroyers, for instance, carried massive stores of spare parts to quickly repair damaged fighters after battles. Although TIE fighters were primarily powered by their solar panels, they still required energy cells for extended operations. These cells powered the laser cannons and other essential systems, and refueling stations were located in every Imperial hangar. While the majority of TIE maintenance was carried out by specialized crews, pilots also had an important role in the upkeep of their fighters. Before each mission, pilots would conduct visual inspections and verify their fighters' readiness using cockpit diagnostics. Pilots were trained to report even minor performance issues, which helped maintenance crews identify and address problems before they became critical. TIE pilots, particularly those assigned to elite squadrons, often became intimately familiar with their ships and could assist in basic repairs or adjustments. However, due to the Empire's philosophy of expendability, most TIE pilots did not develop the same bond with their ships as Rebel pilots often did with theirs. The maintenance of TIE fighters was a vast, complex operation that underscored the Empire's approach to warfare, focused on efficiency, mass production, and overwhelming force. By minimizing the complexity of individual ships and standardizing their design, the Empire was able to field an enormous fleet of starfighters. However, the constant need for repairs, replacements, and upkeep reflected the vulnerabilities of the TIE Fighter's design. Ultimately, the maintenance of TIE Fighters was a key factor in maintaining the Empire's dominance, ensuring that the Imperial Navy could continue to deploy wave after wave of these swift, deadly starfighters across the galaxy. Though the Empire viewed its TIEs as expendable, the dedication and precision of its maintenance teams were essential to keeping the Imperial war machine running. The construction of hangars for TIE fighters was a critical aspect of the Galactic Empire's military infrastructure. These facilities were designed to accommodate the unique needs of TIE starfighters, allowing for rapid deployment, maintenance, and storage. Hangars varied in size and complexity, depending on their location, whether on ships, space stations, or ground installations. TIE fighter hangars were engineered with specific design principles in mind to optimize functionality and efficiency. TIE fighters are relatively small and designed for high-density storage. Hangars often featured modular designs, allowing multiple fighters to be parked in close proximity. The use of vertical storage systems also maximized space, enabling more TIEs to be housed in a given area. The hangars were often equipped with retractable platforms to facilitate quick access to fighters for maintenance and repairs. The hangar's layout prioritized rapid deployment of TIE fighters. Large automated doors allowed for swift entry and exit, enabling TIEs to launch quickly into battle. In larger installations, separate launch and landing bays minimized congestion, ensuring that incoming and outgoing fighters could operate without delay. Within the hangar, dedicated maintenance areas were essential for the upkeep of TIE fighters. These spaces included equipment for routine inspections, repairs, and modifications. Technicians could access all critical systems of the fighters directly in the hangar, which was crucial for minimizing downtime and maintaining the fleet's readiness. TIE fighters relied on solar arrays for energy. Therefore, hangars often included systems for monitoring and controlling temperature and atmospheric conditions. Proper ventilation was necessary to prevent the buildup of harmful fumes from engines or weapons systems. In harsher environments, hangars were equipped with protective shielding and environmental control to ensure optimal conditions for the fighters. TIE fighter hangars came in several forms, each tailored to the operational requirements of the Empire. The primary hangars for TIE fighters were located within Imperial Star Destroyers. These massive ships featured multiple hangar bays capable of accommodating dozens of TIE fighters, along with maintenance facilities and crew quarters. The hangars were designed for rapid launch and retrieval of fighters, with automated systems for transporting fighters to the launch deck. Space stations, like those found in orbit around key planets, also served as hangars for TIE fighters. These facilities often included extensive maintenance and repair shops, and were equipped for long-term storage of fighters not currently in use. The hangars would feature reinforced shielding to protect against potential attacks, and were often monitored by advanced sensor systems to detect any incoming threats. On planetary surfaces, TIE fighter hangars were constructed as part of ground bases or garrisons. These hangars were designed to withstand various environmental conditions, and often featured hardened structures to protect against attacks. The ground hangars provided access to runways for takeoffs and landings, and many were camouflaged to avoid detection by enemy forces. While TIE fighters were known for their agility and versatility in space, their operations on planetary surfaces presented unique challenges, particularly when taking off or landing in unsuitable terrain. The Empire's doctrine often required TIE fighters to engage in combat scenarios that did not always guarantee access to well-maintained runways. TIE fighters were designed primarily for space operations and typically employed vertical takeoff and landing capabilities. This feature allowed them to launch from improvised launch sites, such as rocky outcrops, or even from the surfaces of battleships, without the need for extensive ground infrastructure. However, the landing gear of TIE fighters was relatively basic, which meant that landing on uneven terrain required precise piloting skills to avoid damage. Pilots were trained to assess landing sites quickly, looking for stable ground and avoiding obstacles like boulders or steep inclines. In combat situations, pilots often had to adapt to rapidly changing circumstances, making on-the-fly decisions about where to land or take off. Quick reflexes and adaptability were essential traits for TIE pilots, especially in hostile environments. In scenarios where TIE fighters sustained damage or encountered equipment failures, emergency landing protocols were crucial. Pilots were trained to identify potential landing sites and to execute controlled crashes if necessary. The lack of shields on TIE fighters meant that landing in rough terrain could result in substantial damage. But pilots were instructed to prioritize the safety of the crew while minimizing losses. While TIE fighters did not have extensive modification options, some units were outfitted with specialized landing gear for certain missions. This included reinforced landing struts or adaptive skids designed to absorb shock on rough surfaces. However, such modifications were not standard and often depended on specific mission requirements and available resources. In summary, the construction of TIE fighter hangars was integral to the operational readiness of the Galactic Empire's Starfighter fleet. These facilities were designed with efficiency, accessibility, and maintenance in mind, while the unique challenges of takeoff and landing in unsuitable terrain required skilled pilots and tactical adaptability. The Empire's emphasis on rapid deployment and overwhelming numbers relied heavily on the effective management of its TIE fighter resources, making hangar design and operations a cornerstone of Imperial military strategy. Despite their impressive performance, TIE fighters were not built for durability in the same way as some of their rebel counterparts, like the X-Wing. Key design features that influenced their survivability include: one of the most significant vulnerabilities of TIE fighters was their lack of deflector shields. Unlike many rebel starfighters, TIEs relied on their agility and speed to evade enemy fire rather than absorbing damage. This design choice enabled the Empire to prioritize other features, such as engine performance and armament, but it meant that TIE fighters were more susceptible to damage in dogfights. TIE fighters were constructed with lightweight materials that provided minimal protection. While this contributed to their speed and maneuverability, it also left them vulnerable to even small arms fire and shrapnel from larger engagements. The trade-off between weight and survivability was a common theme in TIE fighter design. The distinctive cockpit of the TIE fighter, while providing excellent visibility, was exposed and vulnerable. The design lacked sufficient armor plating, making the pilot's survival more dependent on their skills and the overall combat environment. A direct hit to the cockpit could quickly incapacitate the pilot and lead to the loss of the craft. TIE fighters were equipped with powerful but exposed engines that contributed to their speed. While this provided a performance advantage, it also created a vulnerability. Targeting the engines could cripple a TIE fighter and lead to a catastrophic failure, forcing the pilot to make an emergency landing or risking an uncontrolled descent. TIE fighters operated in various tactical roles during the Galactic Civil War, and their survivability was often influenced by the strategies employed by both the pilots and their commanding officers. TIE fighters were often deployed in large numbers, overwhelming their opponents with sheer numbers. This tactic aimed to saturate enemy defenses, making it more difficult for opponents to target individual fighters. While this approach improved the chances of survival for individual TIE pilots, it also led to significant losses when faced with coordinated attacks or more advanced enemy fighters. TIE fighters excelled in hit-and-run tactics, utilizing their speed and maneuverability to engage quickly and then disengage before enemy fire could take its toll. This required disciplined flying and coordination among pilots, allowing TIE squadrons to strike at critical targets and retreat before facing retaliation. In certain operations, TIE pilots would fly in formation to create overlapping fields of fire and protect each other from incoming attacks. This tactic provided some measure of collective survivability, as pilots could cover for one another, allowing for more effective evasion and response to enemy fire. TIE fighters often operated alongside larger vessels, such as star destroyers. This support allowed them to engage rebel ships while being shielded from direct fire from heavier Imperial vessels. However, this reliance on larger ships also meant that TIE fighters could be exposed when acting independently, or when their support was compromised. The Rebel Alliance often employed advanced starfighter designs, such as the X-Wing and A-Wing, which featured superior shielding and armor. These technological advancements put TIE fighters at a disadvantage in direct confrontations, especially when outnumbered or caught in prolonged engagements. The effectiveness of TIE fighters was heavily dependent on pilot skill. While many pilots were trained to operate these starfighters, The Empire often recruited from various backgrounds, resulting in a disparity in experience levels. Veteran pilots faced a significantly higher survival rate compared to inexperienced ones, and the rapid turnover of personnel in TIE squadrons could hinder operational effectiveness. The tactics employed by TIE pilots often prioritized aggression over defense. While this approach could yield quick victories, it also increased the risk of losses. Engaging in close-range dogfights without adequate retreat options could lead to catastrophic failures, especially when faced with well-coordinated rebel tactics. Over time, several specialized TIE variants were developed to improve combat effectiveness and survivability. For instance, the TIE Defender featured advanced shields and weaponry, enhancing the pilot's chances of survival in battle. Similarly, the TIE Interceptor offered increased speed and maneuverability, allowing pilots to evade enemy fire more effectively. The Empire recognized the importance of pilot training and implemented more rigorous training programs for TIE pilots. This focus on tactical education allowed pilots to hone their skills and adapt to the evolving combat landscape, leading to improved survival rates in engagements. As the Rebel Alliance developed new Starfighter technology, the Empire adapted its tactics accordingly. TIE pilots learned to engage in more sophisticated maneuvers, such as coordinated attacks with other Imperial forces, to counteract the advantages of their adversaries. In conclusion, the survivability of TIE fighters was influenced by a complex interplay of design features, tactical roles, limitations, and ongoing adaptations to the battlefield. While they excelled in speed and maneuverability, their lack of shields and light armor made them vulnerable in direct combat. However, through the use of swarm tactics, hit-and-run engagements, and the introduction of advanced variants, the Empire sought to enhance the effectiveness of TIE fighters, maintaining their status as a formidable force in the galaxy. The TIE Fighter, or Twin-Ion Engine Fighter, is one of the most iconic symbols of the Galactic Empire's power. While the standard TIE Fighter became the backbone of the Imperial Navy, its basic design was continually modified and adapted to meet various combat challenges and specialized missions. These modifications ranged from interceptors designed for fast-paced dogfighting to bombers capable of delivering devastating payloads. As the Empire expanded its fleet, CNR Fleet Systems developed numerous TIE variants, each addressing specific operational needs and improving upon the basic TIE's design. This text explores the most notable TIE fighter modifications and their roles in the Imperial Navy. The TIE Line, or TIE Line Starfighter, was the most common model used by the Imperial Navy. It was essentially an upgrade of the original TIE Fighter, featuring improvements in engine performance, weaponry, and maneuverability. While it maintained the light armor and lack of shields that defined its predecessor, the TIE Line was built for mass production, allowing the Empire to deploy overwhelming numbers of these fighters across battlefronts. The TIE Line's primary role was that of a multi-purpose starfighter, excelling in dogfights against enemy ships. It relied on speed, agility, and numerical superiority to overcome its lack of defenses. The simplicity of its design also made it cheaper and easier to produce on a massive scale, which was a key factor in maintaining Imperial dominance over the galaxy. While Rebel starfighters like the X-Wing were often superior in one-on-one combat, the Empire's strategy of deploying TIEs in swarms was highly effective in many battles. The tie-in interceptor was introduced as a response to the growing threat of Rebel starfighters, such as the X-Wing, which outclassed the standard TIE line in firepower and durability. The TIE Interceptor was designed with one goal in mind: speed. With a sleeker frame and dagger-like solar panels that reduced drag, the Interceptor was faster and more maneuverable than its predecessor. These design enhancements made it particularly effective in dogfights, allowing it to keep up with and even outpace Rebel craft. The Interceptor's wing design also allowed for the mounting of additional laser cannons, giving it increased firepower. The 4 cannons, mounted at the tips of its wing panels, could deliver precise and powerful bursts of energy, making the Interceptor lethal in combat. While it still lacked shields, its superior speed and firepower made it a favored starfighter among elite Imperial pilots. By the time of the Battle of Endor, TIE Interceptors made up around 20% of the Empire's starfighter fleet, serving as one of its premier space superiority fighters. While standard TIE fighters and interceptors excelled in dogfights, the Empire needed a craft capable of delivering heavy ordnance to ground targets, capital ships, and space stations. The TIE bomber was designed to fill this role. Unlike the single-hulled TIE fighters, the TIE bomber had a distinctive double-hull design. One hull housed the pilot, while the other carried a wide array of bombs, torpedoes, and other heavy weaponry. The TIE bomber was slower and less agile than the standard TIE fighter, but compensated for this with its ability to carry a large payload. It was used in a variety of assault roles, from bombing planetary targets to crippling capital ships. Its reinforced structure also allowed it to withstand longer missions and endure more punishment, although it was still vulnerable to attacks due to its lack of shielding. Nevertheless, the TIE bomber became an essential tool in the Empire's arsenal, especially in sieges and planetary invasions. The TIE Advanced X-1 was an experimental starfighter, most famously flown by Darth Vader during the Battle of Yavin. This variant was a significant departure from the standard TIE designs, incorporating advanced technologies to create a more durable and versatile craft. The TIE Advanced X-1 featured deflector shields and a hyperdrive, two features absent in most other TIE models. These additions made the X-1 far more survivable in combat and capable of independent operations without requiring support from larger capital ships. The TIE Advanced X-1 also had enhanced maneuverability and improved firepower, making it a formidable opponent. Its combination of speed, agility, and durability allowed it to engage multiple enemy ships effectively, even in hostile environments. However, the TIE Advanced X-1 was also extremely expensive to produce, which limited its deployment. It was primarily used by high-ranking Imperial officers and elite pilots, such as Darth Vader himself, rather than being mass-produced for the general fleet. Perhaps the most ambitious TIE variant ever developed, the TIE Defender was designed to be the Empire's ultimate starfighter. Unlike most TIE models, which sacrificed durability for speed and agility, the TIE Defender was equipped with shields, a hyperdrive, and advanced weaponry, including ion cannons and missile launchers. It was intended to outclass any Rebel fighter and dominate space combat. The TIE Defender's advanced systems made it incredibly powerful, but also prohibitively expensive. As a result, its production was limited, and it never fully replaced the more common TIE variants in the Imperial fleet. Nevertheless, it saw action in several key engagements and was flown by some of the Empire's best pilots. The TIE Defender represented the pinnacle of Imperial starfighter design, combining speed, firepower, and resilience in a single package. In addition to these well-known models, there were numerous specialized variants of the TIE Fighter, each tailored for specific missions or operational needs. For instance, the TIE ESK-X-1 Experimental Air Superiority Fighter was designed to test advanced technologies and was often used by the Imperial Inquisitorius. Similarly, the Mining Guild TIE Fighter was a modified version of the TIE line used by the Mining Guild to protect its operations and maintain order in resource-rich sectors. These TIEs featured a distinctive yellow coloring and altered wing panels to improve their performance in industrial environments. The TIE Fighter, in its many forms, was a key element of the Empire's dominance over the galaxy. Each modification, from the agile TIE Interceptor to the heavily armed TIE Bomber, reflected the Empire's evolving needs and strategic goals. While the standard TIE Fighter was mass-produced for overwhelming numbers, its more advanced variants were designed to address specific combat situations, giving the Empire a diverse and powerful starfighter fleet. The TIE Fighter was conceived after 22 before Battle of Yavin, during a time of rapid technological advancement in starfighter design. The basic TIE model, manufactured by CNR Fleet Systems, became the backbone of the Imperial Starfighter Corps. The design philosophy of the TIE series was based on mass production, efficiency, and maneuverability, rather than durability or comfort for its pilots. The early models of TIEs were inspired by advancements in earlier starfighter technologies and were designed to be light, fast, and capable of swarming enemies in large numbers. The basic TIE starfighter served as the Empire's standard fighter, and its iconic twin-ion engines gave it high-speed capabilities, but left it vulnerable due to its lack of deflector shields, hyperdrive, and life support systems. This stripped-down design allowed the Empire to field vast numbers of TIE fighters, enforcing their rule across the galaxy. A notable replacement in this line was the TIE Line model, which became the primary fleet fighter for the Empire. The TIE Line fighter featured improved engines and more powerful laser cannons than its predecessor, giving it an edge in combat. While earlier models were able to match the X-Wing Starfighter in performance, the TIE Line boasted superior speed and weaponry, though it still sacrificed shields and durability. Despite these drawbacks, the sheer number of TIE fighters deployed by the Empire made them an overwhelming force on the battlefield. Throughout the Galactic Civil War, the TIE Fighter became the most recognizable symbol of the Empire's dominance. It played pivotal roles in space engagements, including the battles of Yavin, Hoth, and Endor, engaging rebel starfighters and transports. They were particularly effective against unarmed or lightly defended civilian vessels, which were frequent targets of the Imperial Navy. However, against the more advanced and shielded starfighters of the Rebel Alliance, such as the X-Wing and A-Wing, TIE fighters often found themselves at a disadvantage. The lack of shields made TIEs vulnerable in direct confrontations, and they relied heavily on swarming tactics, where numbers compensated for individual weaknesses. Despite these shortcomings, the Empire's strategy of overwhelming force allowed TIE fighters to maintain a significant presence in nearly every major battle of the war. TIE fighters were also used in infiltration and espionage missions. Rebel forces occasionally captured Imperial TIEs and used them to infiltrate Imperial facilities or carry out covert operations. For instance, after the Imperial I-class Star Destroyer Harbinger was hijacked by Rebel forces, Luke Skywalker and Sana Starros used stolen TIEs as part of their disguise during reconnaissance missions. One early example of rebellion against the Empire occurred on the planet Lothal, where insurgent groups such as the Spectres, who would later join the Phoenix Cell, fought Imperial forces, including squadrons of TIE fighters. These skirmishes marked the beginning of what would later become the Unified Alliance to restore the Republic, officially formed by Mon Mothma in 2 before Battle of Yavin. Following the Battle of Endor and the death of Emperor Palpatine, the Empire found itself in disarray. Supply shortages, leadership fragmentation, and resource limitations hampered the production of TIE fighters. The Imperial fleet, which had once boasted millions of TIEs, struggled to maintain adequate numbers of starfighters, and the quality of pilots also declined as the war dragged on. Imperial Star Destroyers, once bristling with TIEs, now carried far fewer than needed, with many squadrons filled with inexperienced pilots. This shortage severely impacted the Empire's ability to maintain space superiority, especially as the New Republic grew stronger and more coordinated. Despite these setbacks, the legacy of the TIE Fighter endured. It remained a symbol of the Imperial Navy, representing both the strength and brutality of the Empire. Even after the fall of the Empire, many TIEs remained in operation, used by remnants of the Imperial forces, warlords, and even criminal organizations. Over time, some of these ships found their way into the hands of collectors, or were used by local planetary defense forces. CNR Fleet Systems' production of TIEs throughout the Galactic Civil War was prolific, with some estimates suggesting that approximately 4.6 million TIE fighters were manufactured during the height of the Empire's power. This massive production made the TIE Fighter the most numerous starfighters in galactic history,